When we look at water, the first thing that we need to know is the formula for water, and this is something that we've always known from high school. Water is H2O. But when you look at this formula, the way water is that this one oxygen is bonded to these two hydrogens, right? Like that. And you know from your chemical bonding that each atom, for it to be stable, it should either attain duet or octet. There are only two atoms that get stable when they attain duet. That is helium and hydrogen. If I say duet means they become stable when they've got two electrons in the outermost shell, because those are they are in the first period of the periodic table. But the rest of the elements, for them to be stable, they need to have 8 electrons in the outermost shell. So when you look at water, this one bond here has got 2 electrons. So meaning that hydrogen is already stable. Same with the other bond. Even this bond has got 2 electrons. This is telling us that this oxygen has got 4 electrons. So how many is it remaining with for it to be stable? Anyone that can answer us? Since it just has 4 electrons in the outermost shell, how many are remaining for the oxygen to be stable? Okay, someone has said 2. How about others? So it is remaining with 4 electrons. So if you say 2, unless you say electron pairs, because electrons come in pairs, so you are going to have 2 and then 2. So oxygen needs 4 electrons or 2 electron pairs, right? It's the same language. But because of this, in the previous class we talked about chemical bonding. In this bond, you have got electrons, and these are electrons. Electrons are negatively charged, and you know from your physics, like charges repel. So what will happen is that these electrons in the bond and this lone pair of electrons will be pushing against each other. Same also, these electrons and these electrons will be pushing against each other. Again, these electrons and the electrons in this bond will be pushing against each other. So what you are going to be able to see is that water is not going to be straight. Instead, it is going to end up like this. And the aim as to why it is even ending up with this shape is so that electrons can have maximum distance away from each other, like this. We call this shape as a bent shape. It's also known as a V shape because it looks like a V if I had put the hydrogens on top like this. So this is the structure for water. So if they ask you what is the structure for water, it is not linear, it is V shaped. Okay. Now another thing that we need to understand about this shape is what we call dipole moments. When you check the periodic table, something like this, you are going to have an element fluorine at this point of the periodic table. So fluorine is the most electronegative atom on the periodic table. What we mean if we say electronegative, it means that when there is a chemical bonding, okay, let's say there's a bond between hydrogen and fluorine, you can see this is a covalent bond, and the covalent bond, there is sharing of electrons. It's like fluorine has said, okay, I've brought my electron. Hydrogen has also said, okay, I've brought my electron. But since fluorine is more electronegative, it's like that a small boy and a big boy bring their food together. When they start eating together, they will not eat equally because a big boy will eat more. So fluorine is going to attract those 2 electrons towards itself. Why? Because it has got a greater affinity or greater love for electrons than hydrogen. So that is what we call electronegativity. So as when you check on the periodic table, since we said fluorine is here, as you move near to fluorine, atoms become more electronegative. In other words, atoms tend to have a much higher ability to pull electrons towards themselves. Now oxygen is in group 6 somewhere here, while hydrogen is in group 1 like somewhere there. So you can see that oxygen is much near to fluorine, meaning that oxygen is more electronegative. So the bond between hydrogen and oxygen in water is going to be in such a way that electrons are pulled more towards oxygen. So this is how you write. You are going to write an arrow towards the most electronegative atom, and then you are going to put a line like this. We call this as a dipole moment. Dipole moment. And then that will be also the same way in this direction, like that. Now from physics, the next topic we'll be doing in physics will be vector. So you are going to understand that when you have got a vector going at an angle, because vectors can go horizontal or vertical. So if you have got a vector that is going at an angle, it means that it has got two components. It has got a component going in the y, we call that as a vertical component, and the component going in the x, that's a horizontal component. So this vector is going to have those two components. But remember, you have got another one, which is this one, and it is going like this. So this one also is going to have components, one going up, one going like this. But because this vector and this vector, they have got equal magnitude, meaning that they have got the same size. In other words, you are pulling and I'm also pulling. If we are pulling at the same force, there will be no movement. So these two vectors will cancel themselves out. And these two vectors, can you see that they are both going up? They are going to add up. This is telling you that in water, the net dipole is towards oxygen. The net dipole goes towards oxygen. Like this is the net. Meaning that oxygen is more electronegative and it will be pulling electrons towards itself. So why should we understand this? When an atom pulls electrons towards itself, it is going to carry a partial charge. Partial means half, because ionic compounds like sodium and chloride, when they react, they are going to form sodium chloride. These ones have got full charges. Can you see that? Sodium is having a positive 1 charge, chlorine is having a negative 1 charge. Those are full charges. But for covalent bonds, they don't form full charges. It is just partial. Why? Because there's no complete loss and no complete gain of electrons. It's just sharing of electrons. So since oxygen is the one that is carrying electrons more, it's not like it has gained, but the electrons are just more nearer to oxygen. It's going to carry a partial negative charge. Why negative? Because oxygen is pulling electrons towards itself and electrons are negative. So if I pull negative things from you, you are going to remain positive. Just like the bad energies of 2024, leave them in 2024 and carry on with good energies in the new year. So hydrogen, because we have put electrons which are negative away from it, it is going to remain partially positive. And same way with this side, oxygen is going to be partially negative while the hydrogen is partially positive. So we say that oxygen has got two partial positive charges. I mean two partial negative charges. Okay, we can write like that. While each hydrogen has got only one partial positive charge. Does this make sense?
So
Yes, please.
you say that a dipole moment. Okay, let me try to get this straight. It is more like when since oxygen is pulling electrons towards itself, which makes it more electronegative. Does it mean that that is called a dipole moment?
Okay. Yes, basically that. So a dipole moment is just a representation showing us which direction or which atom is more electronegative in comparison to the other atom. Okay, so for us to show, we can use just a line that's going to be a dipole moment. So if you hear a molecule, because water, one thing that I'm trying to explain here is the first property of water is that water is dipolar. Okay, we can say dipolar or bipolar, since the word bi and di both means two, right? So you can see bipolar or dipolar. So water is dipolar. The meaning of that, it has got the negative end, which is basically the oxygen, and then it has got the positive end, which are the hydrogens. That's the meaning of water being bipolar or dipolar, and the explanation is just the one that we've given here. Does that make sense?
Yes.
Okay. So again, if we say water is dipolar, you need to understand what's the meaning of the word polarity. So polar or polarity is just the unequal sharing of electrons. Unequal. There is no equal sharing. We can say unequal or uneven electron sharing. It means that one of the atoms is pulling electrons to itself more than the other one. So that's why the unequal sharing of electrons. So this is the first property of water. Water is a bipolar molecule. You know the importance of this property is that it will make water to interact with other polar molecules. For example, when you see sodium, sodium is positive. So what will happen is that sodium is going to be surrounded by water, but the surrounding is going to be in such a way that the negative parts of water are the ones that will be able to be near the sodium. For example, you are going to see it like this. So when sodium is surrounded by the water, it is actually oxygen that is going to surround the water like this. Why? Because hydrogens are positive. The hydrogen which are positive will be pushed by the positive sodium, and we actually call this as solvolysis. So what happens that when you get salt, you put it in water, the salt is going to be broken down. The positive ion is going to be surrounded by water, the negative ion is also going to be surrounded. So for the chlorine, what you are going to see is also going to be surrounded, but then it's going to be like this. Look at the way it's surrounded, a bit different from the way the sodium has been surrounded. Why? Because in this case it's supposed to be the oxygen, the hydrogen, which is the positive, right, interacting with the chlorine, which is negative. So they can actually give you a question like this in the exam. Maybe they can write something that is negative, or they'll just put a positive and then they write like this. They put my dots like so, and then they tell you this is a water molecule. They tell you what element is this one, which is here. So since this is a positive charge, you're expecting that this element should be negatively charged. And which one is that which is negatively charged? Supposed to be the oxygen, but not even the way I've written here, because you don't have two oxygens. So I'm supposed to put a negative. Let's say this is a negative thing here. So meaning that these guys are supposed to be positive. So those are hydrogens. So hope this is okay. Hope that's okay. The next property of water that you need to know is that water can form hydrogen hydrogen bonds, right? Hydrogen bonds. It can participate in the formation of hydrogen bonds. Now, hydrogen bonds are actually formed between hydrogen with either oxygen, fluorine, or nitrogen. These are the most electronegative atoms. So what happens that water can form hydrogen bonds with another water molecule, or it can form hydrogen bonds with other molecules other than water, as long as they have got oxygen, fluorine, and nitrogen. For example, we're going to see water like this. It can interact with another water molecule like that. But hydrogen bonds, you don't use full bonds, you are going to put dots. Hydrogen bonds are weak bonds. Remember from the chemical bonding, we said that the strongest bonds are covalent bonds followed by ionic and then hydrogen bonds and then van der Waals forces, which are also known as London dispersion forces. So the hydrogen bonds are weaker, but they are longer. You can see the distance here is longer than this distance. But because in water you have got a lot of hydrogen bonds, they end up being very strong. That is why it is impossible, nearly impossible, for you to have one water. You are going to find water together because these bonds are such a lot that it is very difficult for you to separate this. For you to have only one water, you say, oh, this is one water, this is two, three. No, it's not possible. Okay, so that is what we need to be aware of. Besides this, this same water can form hydrogen bonds with other molecules. For example, esters or not really esters but carboxylic acid. The carboxylic acid is like this. It has a double bond with oxygen and then it has got an OH like that. So what can happen is that this oxygen in the in the carboxylic acid can interact with the hydrogen. Same way this hydrogen can interact with the oxygen in water to form those hydrogen bonds. Okay, so that's a basic thing there. And then now specific other properties of water that we really need to be aware of. Other properties. Number one, so those two I've mentioned, bipolar, that's the nature of water, and hydrogen bonds is the nature of water because of it being bipolar. But the actual properties that come because of water being bipolar and being able to form hydrogen bonds. Number one is that water is an excellent solvent. We call it the universal solvent. The meaning of universal solvent is that nearly anything that we know, nearly, I've not said everything, nearly everything can dissolve in water. Okay, so ionic substances can actually dissolve in water, and also other molecules can interact with water and then they'll be separated. And the only substances that are going to dissolve in water are those substances that are polar. And this is very important. Water will only interact with polar molecules, not non-polar molecules. Examples of non-polar molecules that we can mention are lipids. This is actually a topic, we'll talk about it. So you have got different types of lipids. Let's just say cooking oil. Cooking oil is a type of lipid. So if you get cooking oil, you put it in water, there is no way they are going to mix. Why? Because lipids don't form hydrogen bonds. Why? They are non-polar, and the reason for that is because they have got a lot of carbon hydrogen bonds. A bond between carbon and hydrogen is different from a bond between hydrogen and oxygen. This bond is a polar bond. The meaning of that is that you are going to have a dipole going in this direction. But the bond between hydrogen and carbon is a non-polar bond. Why? Because all these, both carbon and hydrogen, have got weak electronegativity. So carbon, even if it is a bit strong than hydrogen, it doesn't have much capacity to pull electrons away from the hydrogen. And so in this molecule, electrons are going to be equally shared between hydrogen and oxygen, hydrogen and carbon. While in a molecule that contains these bonds, electrons are not going to be equally shared. That is why we are going to have polarity. There's going to be a positive end, a negative end. But in molecules like this, there's no positive and negative end. This tells you why organic compounds are non-polar. Things like alkanes, alkenes, alkenes, they are non-polar. Why? Because they have got a lot of carbon to hydrogen bonds. So those things cannot dissolve in water. Things like alkanes, methane, ethane, they can't dissolve in water. Does that make sense? Is there any question?
Yeah, he said the organic compounds cannot what?
organic compounds won't dissolve in water. And of course, not all organic compounds. I've mentioned the specific ones: alkanes, alkenes, and alkynes. They will not be able to dissolve in water because they are non-polar. But you have got other organic compounds like alcohols and carboxylic acids. Those can dissolve in water because they have got oxygens in them. Does that make sense?
Yes.
Okay, thank you. The second property of water that we need to know is that water has got a high specific heat capacity. If we say specific heat capacity, I can give an example. Okay. Let's say you have got water in a jug or something. This water, let's say it is at 25 degrees Celsius. And let's say the water here, the mass of this water is actually 1 kg or 1 gram. Because we normally work with small numbers, not kgs are too big. So I've got 1 gram of water at 25 degrees. If I want to change the temperature from 25 degrees to 26 degrees, you can see I want to raise the temperature. What's the difference here from 25 to 26? This is only 1 degree Celsius. So we define specific heat capacity as the amount of heat energy, because you need to put heat here. You are going, let's say maybe there is a candle there that is burning, you need to put heat here, and that heat, what is going to happen is that it will start raising the temperature. So specific heat capacity is the amount of heat that is required to raise the temperature of 1 gram of a substance by 1 degree Celsius. We just want to raise the temperature of 1 gram by 1 degree. If I remove the word specific, then I'll define heat capacity as the amount of heat energy that has to be introduced to a compound to raise the temperature by 1 degree. So the word specific is just meaning 1 gram. So we want to raise the 1 gram of water by 1 degree. Okay, so that's the meaning. Now this tells us that for water, for if water is at 25 degrees, for you to change that water to 26 degrees, it is going to be very hard. In other words, you need a lot and a lot of heat just to change the temperature of water by 1 degree. So for each one of the properties of water, you need to know the definition and the importance, biological importance. So what is the importance of using a lot of heat to change the temperature of water just by 1 degree Celsius? The importance of that is this. Let's think of, what can we think of? Okay, let's think of a pool, all right, a water body. Let's say, for example, a river, or just anywhere where you have got animals. So what happens is this: here is the water in the pool, and then you have got fish there or something. Or we can talk about our own bodies, right? Our body as a human being. 60% of the body is made up of water. 40% is what is made up of what you can see as these muscles and these other things. So the thing is that we have got enzymes in our bodies that help in different reactions. So without those enzymes, we can't make energy. Without those enzymes, we can't break down the food that we eat. And so meaning we are going to die. And those enzymes work in an aqueous environment. They work in water. And one of the things that affect the function of enzymes is actually a topic, we'll do it. One of the things that affect the function of enzymes is heat or temperature. So if you raise the temperature too much, the enzymes are going to become deactivated. They are going to be killed, denatured. So the meaning of that is that if let's say this enzyme works well at 25 degrees Celsius. If I change the temperature from 25 degrees to 26 degrees, I've killed that enzyme. But because it is very hard to change the temperature of water from 25 to 26, even when it is hot, that hotness is not strong enough to change the temperature from to change the temperature just by 1 degree Celsius. And so we are protecting or maintaining a constant internal environment. And maintaining a constant internal environment, we call that as homeostasis. So this property for high specific heat capacity is important for homeostasis. It is going to help us not to destroy the enzymes that are in our bodies. Okay, why? Because biochemical, bio means living. The reactions that happen in our body depend on enzymes that are very sensitive to heat and temperature changes. Does this make sense?
Yes.
Very good. Okay, so that is what we have to know there, and that is very important for us to know. The third property of water that we should be aware of is that water has got a high latent heat of vaporization. Now, latent means hidden. Vaporization is to change a liquid into a gas. So what happens is this. When you have got, let's say this is a cooling cave, a heating cave. You have got water, you are heating water. So this side is going to be showing us the temperature. Water, this is 0 degrees. Water below 0 degrees is actually ice. So if you have got ice at this point, what happens that when you start heating ice, when you start adding heat to ice, it will start changing, it will start going like this. When it reaches 0 degrees, what will happen is that that ice will start being converted into water. So can you see that the line here is straight? Because at the point when a change of state is happening, temperature doesn't change. Not until, because remember here this was a solid, it was ice. At 0 degrees, if I continue heating, the solid, you are going to have, at this point you have got some solid, a mixture of solid and liquid. That's where if you remove ice from the fridge, you are going to have that point where I've got some water inside and some ice inside. So that is change of state is still happening. So we call this, okay, I'm going to mention it. But when I continue increasing the heat, I'm going to convert all the ice into liquid. So now at this point I'm going to have liquid water. So this point here, the change from solid to liquid, this is known as melting. So 0 degrees is actually the melting point for water. And then when I've got this liquid water, if I continue increasing the temperature, when I reach at 100 degrees, what will happen is that change of state again will be happening. So the graph will again flatten. At the change of state, you can see the graphs flatten because now we are changing the liquid into a gas. Once all the water has been changed into a gas, the graph will start rising again. At this point, change of liquid to gas, we call this as vaporization or evaporation. And, or we can say boiling, and the boiling point for water is 100. So because at this point when change of state is happening, the graph is straight, we call it latent. You have got heat, but that heat is hidden. You can't see it because for you to see heat, you should be seeing a change in temperature. But at the change of state, you don't see any change in temperature. That's why we call it latent. It's hidden heat. So there is actually heat there. But that heat is hidden. It is changing a liquid into a gas. That is latent heat of vaporization. Now, what is the importance of this property? The importance of this property is we can mention for cooling effect. It is very hard for you to change liquid water to gas. In other words, we are saying latent heat of vaporization is high. The meaning of that is that immediately you convert liquid water to gas, it means that you have taken in a lot of heat. That's why the latent heat is high. So in our bodies, let's say if we're in October, it is very hot. For me to because in our bodies we have got water. For me to sweating means I've converted the liquid water that was in my body into gas. For me to be able to sweat, it means that I've lost a lot of heat from the body. That is the only way the liquid that was in my body could be converted to gas and then it appears as sweat. So sweat is important for cooling. Why? Because once you sweat, it means that you have lost a lot of heat from the body. So that is the importance of this property. Dogs also pant. You see the dog removes the tongue, right? It is trying to lose water also if it is hot, and that is a cooling effect that happens also in the dog. Plants also will undergo what is known as the transpiration, where the leaves are going to be losing water, and as they lose water like that, they're actually also losing heat. Okay, so all that is basically for the same purpose. Does this property make sense? Okay, great. The next property that we need to know about water is a property related to density. If you did pure sciences or even just ordinary sciences, you should have learned in physics what is known as the anomalous expansion of water or the abnormal expansion of water. What happens is this: normally, for normal compounds or liquids, when you get a liquid, you start boiling it, right? Boiling. It's supposed to expand, supposed to become bigger. But water does it differently. For water, whether you are expanding it or you are cooling it, it can still expand. That is known as the anomalous expansion of water. Actually, the density of water is densest at 4 degrees Celsius. This is where it is very, very, very dense. Below 4 degrees, it is not very dense, and above 4 degrees, it's not that dense. Isn't it that just weird? Okay, so let's say here is water at 4 degrees Celsius, and the y-axis is representing density. So what will happen is that at this point water is very dense. When you increase the temperature of water beyond 4 degrees, the density is dropping. And as you get to increase, actually I can put the graph go like this. And as you get to increase the temperature of water towards 4 degrees, the density is increasing. You can see how this is weird. So water is densest at 4 degrees. The importance is that if you have got a river, okay, so water that is at 4 degrees, at let's start with 0 degrees, that is ice. Ice is less dense. Ice is less dense. So ice is going to be on top of water. And as you get to go down the river, the density of water is increasing. The densest is going to be at the very bottom. So water that is at 4 degrees is at the bottom. And then 3 degrees there, 2 degrees, 1 degree. So what happens is this: in June or in cold season, because at the surface water is a bit more cold, you can see the temperature is so low, it has even formed the ice. Fish is going to go at the very bottom. The fish is going to be down here, and so you can't fish in June. Why? Because fish has gone so much down and you can't find it there. So this the property of water for density helps aquatic life to survive. Even when it is very cold, aquatic life can actually just move to the bottom, and then they'll be able to survive at the bottom. Now another property that I want you to understand about the density of water is that liquid water, look at this, from your properties that you learned in high school, if you have got solid, liquid, and gas, it's like this. Solid, the particles are very much closely packed. If you remember, particles are very closely packed. In liquid, at least particles are a bit spaced, they have got some space. And then in gas, the particles are freely movable, they can move in any direction. That is, if you can remember the Brownian motion, they can, the particles can move in any direction. But this is different for water. For water, the solid is actually having space. The liquid is the one that is very much packed. That is why for water, solid water is going to be at the top, like ice is going to be at the top of the river, while liquid water is going to be at the bottom because it's the one that is more dense. Okay, that is important to know. Another thing that we have to know about the density of water is that when you look at these water molecules, each, yes please.
Sorry. You said, so I didn't get on the solid liquid, like which one is being on top of the other?
So for water, the solid is going to be on top, like the ice is going to be on top, and then the liquid water is going to be at the bottom because the liquid is more dense. So since the liquid is more dense, it's going to be at the bottom. This is different from the rest of the compounds because solids are more denser than liquids. That's why solids will be able to sink, right? But this is different for water. Does that make sense?
Yes.
Okay, good. So another thing that you need to know about the density for water is that for solids, for solid water, each water molecule, each, so if I've got one water molecule, it is going to form four hydrogen bonds with other water molecules. Four hydrogen bonds. Like if this is one water molecule, it will be forming four bonds with four other water molecules. But for liquid water will form, it doesn't form like a specific number of hydrogen bonds, so we just give the average. We'll say the average of the bonds that liquid water will form is 3.4. Why do we say average? It's because water, which is liquid, the bonds are constantly breaking and forming. This explains why water is able to flow. You know, flowing, huh? If you get a cup of water, you pour it on your hand, water will be able to move down your hand. Why? Because hydrogen bonds will be forming, breaking, forming, breaking, forming, breaking. That is allowing the water to move. But for solids, it has got fixed hydrogen bonds, so it can't flow. Solids can't flow because of the fixed bonds, right? So that is about the property of water, looking at its density. Is there any question about the density of water? So number 5 property is related to, I'm going to combine three principles. Actually, it's supposed to be different, but let me talk about them differently. Okay, there is cohesion. Cohesion will be going together with surface tension. Co means same, so cohesion means coming together. Every time one water molecule is moving, it attracts other water molecules. There is no way that no one water, I've seen one water moving alone. No. Every time a water molecule is moving, it will move with other water molecules. This property is important for surface tension. When you look at uh, a river or anything, or any pool of water, what you are going to see is that water molecules on top are going to form more like a glass. They form more like a glass on top, and that glass that they are forming on top, these are water molecules, is because each water molecule is attracted to another water molecule. If there's a water molecule is bonded to another water molecule, are bonded to another, bonded to another, so they are like holding like that. This forms like a thin sheet on top where an insect can come and sit here. It will not sink. Why can insects not sink here if they can sit on water? It's because one water molecule holds another water molecule, and that forms more like a thin sheet where insects are able to sit. You are actually going to do this experiment in biology. That should be experiment 1 in your biology labs. You are going to get a glass clip. You are going to put water on this glass clip, and then you are going to get another glass clip. You put it on top. What you are going to see is that you will not be able to separate these two glass clips. They have held to each other. But that one is going to be because of another property that I'm about to mention. So surface tension is just telling us about that sheet that is formed on top, okay, because of cohesion, because water molecules are attracted to other water molecules. So you have got that sheet formed where insects are able to float. That is surface tension. This is important for insects, okay. And at the same time, when you look at this surface tension, the surface tension also exists between the molecules as a result of course, surface tension exists because of cohesion. That is going to create a layer over the water, as I've said, and that is going to allow insects to be able to flow. I think that that's the best thing that I can mention, and that's what you need to know with the application. The other property you need to know is adhesion. Adhesion and cohesion, they're just opposites. So cohesion is attraction, or molecules that are of the same form attracting each other. But adhesion is different molecules attracted to each other. Adhesion is important in getting wet. Okay? Like, why do our clothes get wet? Water can adhere to surfaces other than water. That's why they can be able to make other compounds to be wet. Actually, when you get a glass cup, you put water there. Even when you try to remove all the water, you're going to still see some water on the glass cup. And that is because water is attracted to other molecules. That's known as adhesion. But for wetting to happen, for clothes to get wet, you need both cohesion and adhesion, because adhesion will allow the water molecule to attach to the cloth, but cohesion will make sure that that water molecule also attracts other water molecules to also attach to the cloth. So wetting will apply both, but the most is adhesion. The last property of water that we need to know is known as capillarity or capillary action. Capillary action, this just tells us that when we have got water, okay, water can be able to flow in a tube. If you remember in high school, you talked about the xylem and phloem. In the xylem, what happens that you have got a plant, and then water will be able to move down, going up. Why is water moving upwards against gravity? There is nothing that is pushing. It's not like we are pumping water. Why is it moving? It's because of the two properties that we have talked about, cohesion and the adhesion. What will happen is that when you get a small glass that is open at both ends, put your thumb first on this end. You put your thumb, and then get this glass, come and put it in water, and then remove your thumb from the top. What you are going to see is that water will now move up. That is known as capillarity or capillary action, and it is happening because water is going to be attracted to the wall of this glass by adhesion. At the same time, water will be attracted to other water molecules by cohesion. So that is capillary action. Capillary action is important in getting to move water from the underground, taking it up so that plants can be able to receive the water that water is necessary for the plant to be able to grow. When you look again at water, when you get a test tube, water is going to appear like this in a test tube. The reason as to why water appears like this, it forms a lemniscus like this, is because adhesion in water is actually greater than cohesion. You can see why is it that at the ends here it is more higher than on the middle here. That is because water is more attracted to the glass than it is attracted to itself. So adhesion is greater than cohesion. This is different when you look at mercury. When you get mercury, it is also a liquid. You put it in a test tube, you are going to see mercury will look like this. Why? Because for mercury, cohesion is actually greater than adhesion. The molecules are more attracted to themselves than they are attracted to the surface of that container. So, my friends, this is water and its properties.